Today we are doing Math 6, Mission 2, Lesson 11, representing ratios with tables. All right, so let's do our warm-up. Look for a pattern in the figure. Well, I see that there are 3 gray tiles and then 4 darker, we can say black tiles. And in the next one, I see that there are 3 and 3, and then there's another column or row of 4 and another row of 4. And then in the next one, I see 3 rows of 3 and 3 rows of 4. So the pattern that I can see is that each time we get a new figure, both colors go up by the same amount, right? So it's like we're adding another layer to both sides. So to go from here to here, we get another layer of 3 and another layer of 4. To go from here to here, we get another layer of 3 and another layer of 4. So it asks, how many total tiles will there be? Well, here we would do 3 plus 4, which is 7. Here we would do 3 plus 3, which is 6, over 4 plus 4, which is 8. So we have like a 6 to 8, which when we add them together gets us 14. And then here we have 3, 6, 9, and 4, 8, 12. And when we add that together, that really gets us 21 tiles, okay? So this is like doing 1 group, 2 groups, and then 3 groups of that original group. So the fourth figure, what would the fourth figure look like? Well, the fourth figure, I would say we would have a 3, 3, 3, 3. So we'd add one more line of 3 and 4, 4, 4, 4, another line of 4. So that would get us 3, 6, 9, 12, and 8, 12, 16. And that would get us 28. So for the fourth figure, there would be 28 tiles, total tiles. What about the fifth figure? Well, the other thing I noticed, instead of just drawing more of these diagrams, I noticed that we have 7, 14, 21, 28. So this is kind of like taking the original. To go here, we would multiply by 2. To go here, 7 times 3 is 21. And to go here would be 7 times 4, which is 28. So I can look and say, well, what's 7 times 5? 7 times 5 is 35. So there must be 35 tiles in the fifth figure. And the 10th figure, I can go, oh, what's 7 times 10? 7 times 10 is 70. So there must be 70 tiles in the 10th figure. How do you see it growing? Well, each figure is, what do we want to say, is being multiplied by 7? So it's basically growing by 7 each time. All right. Now, activity 1. Noah's recipe for 1 batch of fruit punch uses 4 liters of orange juice and 5 liters of strawberry juice. So we've got fruit punch again. Use the double number line to show how many liters of each ingredient to use for different sized batches of fruit punch. All right, so initially there's 0 liters of orange juice, 0 liters of strawberry juice. 1 batch, so if we're doing 1 batch, that'll get us 4 liters of orange juice and 5 liters of strawberry juice. If we're doing 2 batches, that will get us 8 and 10. 3 batches will get us, 12 and 15. 4 batches will get us 16 and 20. 5 batches will get us 20 and 25. 6 will get us 24. and 30. 7 will get us 28 and 35. 8 will get us, 32 and 40. 9 batches will get us 36 and 45. And 10 batches will get us 40 and 50. All right, if someone mixes 36 liters of orange juice and 45 liters of strawberry juice, how many batches would they make? 36 liters of orange juice. So here's 36 liters of orange juice. So that would get us right here. How many batches? Well, we can look right there. That will get us 9 batches. Okay, if someone uses 400 liters of orange juice, whoa, that means that I have to continue this double number line out to 400. Yikes, I don't want to do that. So maybe I can use some logic here. Right here is 40 liters of orange juice, right? So 40 liters of orange juice for 50 liters of strawberry juice. So, and they want to know how many 400 liters of orange juice, how much strawberry juice would that be? So 400 OJ to how much strawberry juice? Oh, okay. Well, I know 40 times 10 gets me 400. So 50 times 10 would get me how much strawberry juice we need. So 50 times 10 is 500. So we would need 500 liters of strawberry juice. That would be really hard to do on a number line, a double number line. Like we would have to do all of these little to get up to 400, show it on a double number line. I'm glad I know equivalent ratios just get multiplied by the same factor each time. All right, let's do this. If someone uses 455 liters of strawberry juice, how much orange juice would they need? Well, let's look. So I know my original ratio is 4 to 5. So I know that 5 times something has to equal 455. Well, I know 5 times 9 gets me 45, and 5 times 1 gets me 5. So 5 times 91 should get me 455. Wow. Yikes. I would have to do 91. Oof, that'd be too much. Okay, so, but I know that if we multiply one side by 91, to get orange juice, we would take the original of orange juice, which is 4, right? So we would have to do 4 times 91 to get how much orange juice there would be. So we do 4 times 91. And I know that equals 364. Okay, because 4 times 1 is 4, 4 times 9 is 36. So 364. So we would need 364 liters of orange juice. Yikes. That would be really hard to show on a double number line. You would need a massive double number line to do this. So, explain the trouble with using a double number line. There's not enough room. Basically, there's not enough room. We could do it. It would just take forever. So it'd take too long. Yuck. I don't want to do that. All right. So if we don't want to do double number lines because we're working with such high numbers or possibly such small numbers, there's a different way we can do this. Here we go. A recipe for trail mix says mix 7 ounces of almonds with 5 ounces of raisins. Here is a table. So now instead of doing double number lines, we are going to learn a new tool, which is called a table. That has been started to show how many ounces of almonds and raisins would be in different size batches of this trail mix. So if you notice, each one of these has a heading. It's always important to label, just like we do on a double number line, where we have our labels, okay? We must label our tables, okay? Now, the things going down are called columns, okay? And the things going sideways or across are called rows. And of course, I did not spell that correctly, so we're gonna change that. All right, so these are columns and these are rows, okay? So the first column deals with almonds. The second column deals with raisins. The rows are the equivalent ratios. Now, what's great about a table is every piece of information in the table is a part of an equivalent ratio. Okay, so let's complete the table so that the ratios represented by each row are equivalent. Okay, here we go. So instead of going across like in a double number line, right? If we had 7 and 5 and we wanted to get to 28, we would go this way, right? Instead of going across, now we're going down. Okay, so 7 times what equals 28? Well, I know 7 times 4 is 28. So I'm going to do 5 times 4 to get my new number for this row, which would be 20. So 7 to 5 is the same or equivalent ratio as 28 to 20. Now we need to keep going. Well, I don't know what this is, but I look to the other side and I have a 10 here. So 5 times what gets me 10? 5 times 2 gets me 10. So 7 times 2 is 14. Now, if you notice, these numbers in the table aren't going in order like they did on the double number line. That's okay. The table is there just to keep our understandings in order. Almonds go in the first column, raisins go in the second column. But we can go in any order we want to within the table. So it makes it really nice because we don't have to have this evenly spaced double number line in order to find what we need. All right, so now we have 3.5. Well, I know that 7 times 1/2, or divided by 2, gets me 3.5 because 3.5 times 2 is 7. So now I need to do half of 5. So I need to multiply 5 by 1/2. Well, that would get me 5 over 2, but because everything is in decimals in here, we're going to stick with decimals. So that is 2.5. Half of 5 is 2.5. Now, what's also really cool about a table is I can use any number that I want. Right now, we've been using our first ratio, but for 250, I could go to 10 and I know 10 times 25 gets me 250. So what is 14 times 25? Right? So 25 times 14. 4 times 5 is 20. That's 8. That's 10. 5 and 2. So that gets me 350. So you don't always have to use the beginning ratio number. You can use any number that helps you best get to where you need to go. All right, so now our last one is 56. Well, I'm going to go with the first one because I know that 7 times 8 gets me 56. So 5 times 8 is 40. Okay. So now we've completed our ratio. What methods did you use to fill out the table? Well, I just multiplied each number by the same number that's non-zero, because it can't be 0 because anything times 0 is 0. So that doesn't really help us. So I multiplied each side of the ratio, or the table, right, by the same number. How did you know that each row shows a ratio that is equivalent to 7 to 5? Because I multiplied 7 and 5 by the same number. And so when I did that, each row has a value of a ratio equivalent to the original one, that 5 to 7. When you multiply both sides of the ratio, 7 to 5, by the same number, the subsequent ratios, the ratios that come, as a result of multiplying, are equivalent to the original ratio. Okay. Please make sure you are going through your lesson summary.